Section 3.2 on page 171 talks about properties of determinants. We dealt with determinants a bit in the previous section 3.1, and we dealt with that when we talked about inverses back in chapter 2.2, I think, 2.1. So let A be a square matrix. That means A is an n by n. The number of rows equal the number of columns. If a multiple of one row of A is added to another row to produce another matrix, the determinants are unaffected. They're the same. If two rows of A are interchanged to produce B, then the determinant of A will be negative the determinant of B, or vice versa. And if one row of A is multiplied by K, a whole row, then the determinant to produce this new matrix B, then the determinant of B would be K times the determinant of A. So it's kind of like when you're given A and you do some manipulation. You know, first step, take row 1 times such and such plus row 2, put in row 2. The new matrix that you get, that's really the B they're talking about. But here we're talking about determinants. We're not talking about matrices. In matrices, interchanging rows has no price. It's the same. It doesn't matter. If you have determinants, remember, with each determinants we have the cofactors. And by changing a row, you're really altering all of these signs. It turns out that's all you have to remember. So here they say on number 2 and 4, illustrate a property, numbers 1 through 4, illustrate a property of determinants. State which property it is. Can you tell what they did? The first row is unchanged. The second row is unchanged. The third row, they got a 0 there. How do you think they got a 0 there? Well, they must have multiplied row 1 by a -3 and added that to row 3. Put the result in row 3. If you multiply by a -3, -3 plus 3 is 0, -6 plus 7 is 1, and -6 plus 4 is a -2. And that means what? That means they applied 3A, right? What does that mean? No change. Those two determinants are the same. How about 4? Those are the same. Those are the same. They have a 0 there again. If they have a 0 there, I'm going to assume they took maybe negative twice row 1 plus row 2 in row 2. Multiply by -2, added to 2, that's a 0. Multiply by 2, -6, added to 0. Yep, there it is. So again, this is property 3A. Basically, what you need to remember is not the 3A, that it didn't change. In 5 through 10, reduce to raw echelon form. If I want to reduce this to raw echelon form, how does that happen? I'm going to take negative row 1 plus row 2, put the result in row 2. And I'm going to take, actually, how do you like that trick? Didn't say if you multiply a row by a number, it's like multiplying the whole determinant by that number. Now, isn't it easier to say -3 row 1 plus row 2 in row 2 and -2 row 1 plus row 3 in row 3? So this is going to be 3 times what? 1, 1, -1. And that is 0, a 1, a -1, -2 plus 2 is 0, -2 minus -5, and positive 2, that's a -3. And then, wouldn't you say take 5 row 2 plus row 3 in row 3? And that would be a 3, 1, 1, -1. And do you know why we're going for this? 5 plus 0 is 5 minus 5 is 0, and if I multiply this by 5, -5, that's a -8. And if we have a triangular matrix, do you remember the theorem that we said last time? Isn't the determinant of this matrix simply the product of those three? 1 times 1 times negative 8. So what's the determinant of this? A negative 24. How do you like those tricks? So now knowing that, I could take out or multiply by a factor that helps a lot. How about number 8? The same deal. Can I figure out how to find this determinant? Well, I could take negative twice row 1 plus row 3 in row 3. And I would take 3 row 1 plus row 4 in row 4. That would leave me with a 1, 3, 2, negative 4, a 0, 1, 2, and a negative 5, a negative 2, that's a 0, a negative 6, that's a 1, a negative 4, that's a 2, and an 8, that's a 5. And a negative a 3, that's a 0, a 9, that's a negative 1, 3, that's a 6, that's a negative 1, and a negative 12, that's a negative 10. Alright, now what? Now I want to make those two zeros. I could say take negative row 2 plus row 3 in row 3, and take row 2 plus row 4 in row 4. So negative 1, that's a 0, negative 2 plus 2, that's a 0, 5 plus 5 is a 10, and 0, if you add those two, that's a 0, that's a 1, and that's a negative 15. Now, if you notice, I could take row 4 interchange with row 3. What's the price for that? The price for this is a negative. There it is. And that's a negative what? The product of the diagonals, because this is a triangular matrix. And there it is. Let me shift the other problems up. On 15 through 20, well, let's do 16 and 18. It says, find the determinant where given this is 7. So you're trying to figure out what they did. Do you see it seems they only multiplied this by 5? So wouldn't you say that this is 5 times A, B, C, D, E, F, G, H, I, and since that's given to be a 7, wouldn't that be 35? And how about here? I noticed that they changed those two. What's the price for that? If you want to change two of these rows, don't you put a negative? Again, do not mix determinants with augmented matrix. In augmented matrix, you could change rows with no price to pay. These are determinants. Here's a theorem. We came across this before, but here it's official. A square matrix A is invertible if and only if the determinant of A equals 0. If you remember when we were dealing with inverse back in, can't remember, was it 2-1? No. 2-2, there we go. 2-2, we talked about if the determinant is not 0, A is invertible, and if the determinant equals 0, it's not invertible. And I said back then you should just stick with one of those. And what does that mean? Well, if the determinant doesn't equal 0, that means there is a solution. And we know what a solution means by now. Here you're given a matrix. This is not a determinant. This is a matrix. It says, use determinants to find out if the matrix is invertible. Well, how are you going to do that? You need to find the determinant of this. The determinant of this is, they didn't specify how to use this. You could use any method that you like. So since they didn't say, if you make it in reduced row echelon form, we just multiply the diagonal. If you'd rather say, I'm going to go for the shortcut. Remember we did this already? And that would be what? Those three. That is negative 45 plus 0 minus 5 minus a 0, 50, and a 3. This would be a negative 50. This is negative 47 plus 47, which equals negative 3 doesn't equal 0, therefore it is invertible. And the last two problems. Use determinants to decide if the set of vectors are linearly independent. Let's see how that works, if you recall. For them to be linearly independent, we have many ways of doing that. One way is for us to do this. And see if the weights give 0, 0, 0. Right? When they say use determinants, what do you think they mean? Well, if the determinant equals 0, now don't you want this to have a solution? To be 0, 0, 0? If it has no solution, then that would mean that these are linearly dependent. Or simply, I could tie it this way. So again, we're not going to do all of this work. Instead, we're going to tie it down to a determinant, because if the determinant equals 0, then it is not invertible, and therefore it has no solution, which indicate those are linearly dependent. And if it equals 0, well, that means what? I mean, if it doesn't equal 0, that means there is a solution, and they would be linearly independent. So here again, there are many ways. Use determinants. Well, I like the shortcut if it's a 3 by 3. After all, it is called a shortcut for a reason, because it's quick. I copy the first two columns. There's another way of doing this, but let's just stick with one, and I multiply those 3. That would be 0 plus 70 and 21 times 6. What's 21 times 6? 126 minus 0, and those are 20 minus 140, and 42 times 2 is 84. I'll get 70 minus 126 plus 140 minus 84. So I'm looking at 210 minus 210. I get a 0. If the determinant equals 0, that will mean what? That means there's no solution. Linearly dependent. One of them is multiple of the others. One of these rows is multiple of the other. Again, there are many ways I could show that. They're asking us to use determinants. And how about this 4 by 4? 3, 2, negative 2, 0, 5, negative 6, 4, negative 6, 0, 7, negative 1, 3, 0, 0, 0, and a negative 2. I can't take a shortcut, but I could pick this row, and basically the only thing that's going to be left is a negative 2 times cross its row and column, a 3 by 3, right? And I could use the shortcut on the 3 by 3. Oops, got carried away there. And say that is a negative 2 times, and again, nine, negative 54, 2 times 1, negative 2, 12, plus 0, minus 36 times 2 is negative 72, plus 0, 10 plus 30. Negative 2 times, and what is that? Negative 42 minus a negative 42. Is that right? So I'm getting this not to equal 0, therefore linearly independent. And that's really what I'm looking for. And there's the homework. And the only reason I'm having you skip 9 and 11 because I don't want you to find the determinants. You're doing problems like 9 and 11, but I just don't want it to become super long or a hassle.